In this video, we're going to be mostly looking at thermal images, focusing on the 7805. It's a linear voltage regulator. The 78 series, the 05 means that we will give it a voltage of between 7 to 35 volts, and it will output a steady 5 volts. And the rest of that energy, unfortunately, just gets turned to heat. Now, another nice thing about the 78 series linear voltage regulator is that it automatically limits current as needed to protect it from overheating. And so what we're going to do is purposely keep having it overheat, taking a look at thermal images of it overheating, and also we'll see that the LED gets dimmer or goes out completely depending on how much the component needs to reduce current. And we have a 10 ohm resistor. We're not going to see the LED or the protective resistor because it's very low current on thermal. It's not going to get very hot compared to the resistor or the voltage regulator here. And so we will take pictures just with no fan and no heat sink, also with the heat sink, and also just with the fan, and once with the fan with the heat sink. So this is a battery powered fan. You can also plug USB into it. There's 18650 batteries in there. They're rechargeable, but it actually is a pretty good fan for its size. So now the circuit we're going to use, it's already put together. I went over this in the last video. We had the basic schematic for the 78 series, and so this is 05 for 5 volt output. We have, actually it's a 0.47 microfarad, but it doesn't really matter the exact value. The data sheet shows 0.33 microfarad at the input and 0.1 microfarad at the output. So I have two capacitors there. This one's slightly higher, but it doesn't really matter. It will do the same thing. So the input, that's the left pin. I have this jumper from the positive power supply there. And then in the middle, these two capacitors come together at ground, and then we have this jumper to ground. So ground is shared by everything, our 0 volt reference point. And then the LED and the red jumper connect to the output pin right there. I forgot to add the ground symbol there. I added it to the file, so if I upload this later on somewhere, it will be included, but I forgot the ground symbol there. So we have a direct connection from there to there. So 78 series linear voltage regulator here shares the ground with that resistor and the LED. And actually we have the LED before the resistor. They're in series, order doesn't matter. So in any case, that's it. We will give a voltage from the power supply, 7 or more. My power supply only goes to 16, so that's where we're going to stop, 16. And so that will come in, and it will output 5 volts under ideal conditions. It's going to get too hot though, and lower the current as needed to protect the component. So that's one really nice thing about this component. So now let's get to the actual images for this video. So I got the setup I already talked about, and first I took an image of it with my thermal camera with no heat sink and no fan. So that's what we have now. I'll show you the actual FLIR camera I used, but the images aren't going to be picked up near as well on camera as they were on person. And so I tried to get the temperature. This is probably about 230 for the 7805, and then it looks like the 10 ohm resistor is probably about 280 degrees at that point. But the main takeaway is the thermal images help see what's going on, as does the LED. And LED doesn't create enough heat to show up. But in any case, we will look at the voltage coming in, and everything shares the same ground. We put the black probe there, and then the input, it's showing a little less than 6 or a little less than 7 volts, but it's actually 7 volts coming in. So I think we just kind of have a voltage drop going through there. But now we go to the other side to the output of the 7805, and there you can see it's 5 volts. So it's not going to be exactly 5 volts. It's not that precise, but it's more than 4.9, usually 4.9 and a half or more. And so that's the negative side of the resistor there. I'll go to the other side of the resistor, and you can see we got the same voltage minus a little bit of drop because there's a little resistance everywhere. But for the most part, it's 5 volts. So instead of continuously doing that, I'm mostly just going to show you the images I took already and added notes to them. And we can also get a sense of how much current is flowing from the LED. And so the LED and the resistor will light a certain amount based on the voltage across them. So now, moving along, I skipped some voltages. I went from 7 volts to 10 volts because 9 volts we have the same outcome. I can look at the current the power supply is providing, and it was the same as when I had 7 volts. So I'm at 9 volts now. I'll raise it up to 10 volts. Let's watch the LED. And based on my earlier test, we lost about half of the output voltage because the 7805 warmed up, and so it output less current to protect itself from overheating. And we will actually take a multimeter measurement of this, and I should have took it when we had 9 volts too, but there you can see we got about 10 coming in, and now going out there I got a connection about 2.8, so it's 2.9 now, and it bounces around a bit, but let's go up to the resistor and about 3. So it's going to bounce around, but I think it's going to go down a little bit more and settle at about 2.8 volts. So I'll show you the thermal image of that on the screen right now, and also again I will take one with the FLIR camera in person, and now you can see that the linear voltage regulator is warmer. Looks like it's about 290 probably, whereas the resistor is actually cooling down, and it's a large resistor. It's going to take a little while, but it has less voltage across it because the linear voltage regulator is getting to the point where it's going to overheat, and so it's lowering the current to help keep itself cool. So that's dropping the voltage for the resistor and the LED, but LED still has plenty to be bright. And so that's just it. We just found that 9 volts we can hold the voltage steady, but 10 volts without a heatsink or a fan is too much for it. And so it's protecting itself, which is good. So now the fan does a lot better than I thought it would do. That's why I did the fan first. But I have the power supply voltage now to 14 volts, and there you can see that. And at the output, it's outputting a little less than what the LED needs to light up, 1.6 volts it looks like. And when I added the multimeter, that seemed to help somehow. It passed a little more current and voltage. But in any case, we're going to turn the fan on, and you should pretty quickly see now the LED is turning on. So the fan cools the basic component pretty well. So again, we still got that same voltage coming in, and the power supply is set to 14. And I can see the current rise. Okay, it already rose to about 500 milliamps because we have that 10 ohm resistor makes measuring the current easy. But there you can see now we got 5 volts. So even at 14 volts, I was surprised it was this effective. But I turned the fan off. We should see the voltage dropping like that. And so fan works really great. And so obviously that must be why you see so many fans with electronic components. And so now we got 15 volts with the fan. We should find 4.5 volts out, and then we'll jump it up to 16 volts, and we should find it goes to 4 volts. As we saw with the fan, this goes pretty quickly, and so I'll try to leave time to show images. But there you can see we got 15 coming in minus some losses, and let's get a good connection there. There we go. So it's about 4.8 or so. It's going to bounce around, but earlier I got about 4.5, and looks like it's doing better than it did before. So now I'll share the thermal image right now, but I'm also turning the voltage up to 16 volts, and it looks like I got 400 milliamps of current coming out based on the bench power supply. And so let's prove that it's about 16 volts coming in, and now let's see the voltage coming out. And there you can see it is about 4 volts. So we still have a lot of that 5 volts with the fan just cooling off. It's also cooling off the resistor, so the resistor is going to look cooler on camera too. But the fan's cooling the 7805. This is an L7805, but it's cooling it enough where it's almost providing the full voltage. And now moving along, I turn the power supply off and let the fan cool this down for a while. It's cool now, so it didn't take long. As we saw, fan's really effective. Now we're going to add the heatsink here, and so you just screw it on. There's the screw. It has this little thermal patch or whatever you call. There's also in the kit these little plastic things. I don't know how to use them though, but I got 20 of them. I guess now they only sell 10 of them with the link I provided, but they used to sell 20 at a time. And as you can see here, different size plastic baggies are really nice. So this is one that I bought separately. I just bought an assorted bag of plastic baggies of different sizes. But in any case, all we have to do is set this thermal, I forget what it's called, but it helps transfer the heat from the component to the heatsink. Just kind of set it like that, and I think there's a little oil or something under there. But and then just set that on there and then screw it down. The threads catch into the heatsink and hold, but it's a little tricky getting them into there, so I'm not going to actually show that. Just realize you set that in there and then screw it down with the screw here, and then we can just put it back in the board. So input now is still down here. It has this wire here, which would be nice for soldering it into boards and stuff, but it makes it a little bit harder to put into breadboards. So I find it goes into this gap pretty well if the component is at the right angle. So there we go. I got the input to where the power supply comes in. And but in any case, I think it went into the slot there. But in any case, all the other components are in front of it, so no big deal. So we should be all set now. So now we have the 7805 with the heatsink. There's no fan. Obviously you can hear the fan, even though I don't show it. It's off camera. But when it's on, you can hear it. But there's no fan now. We have 12 volts, and we're getting 5 volts out. So this is the maximum voltage where we're going to have the about 5 volts out. And actually I can't really get to where we come in, but as you can see there, out we have about 5 volts. And of course the better picture was the one I took earlier, but here you can see that heatsink is really warming up, and the resistor also is really warm because it has 5 volts across it. It's a 10 watt resistor, 5 volts across it. I think it's 2.5 watts total, so it can get even hotter. But in any case, there you can see the heatsink heats up. So now I will turn it up to 13 volts, and so now we got 13 volts. We will see that we'll probably get the voltage coming out lowered to 4.3 volts. So, and then later on we'll see about 16 volts to 2.7 volts. So it goes down a bit over time. You can see there's a gap between 13 and 16. So it's not super rapid. The heatsink is helping to reduce it, but actually it's at 13 volts, but it's still holding about 500 milliamps pretty steadily. So I'm going to wait a little while and come back. And so now some time has passed. I noticed on the power supply the current drop all of a sudden. It took a little while though for it to finally kick in, but in any case now we have 13 volts coming in and about 4.3 volts going out. That's what I had earlier. It may change for whatever reason. There we go, 13 volts in, and let's see what it is going out. So the best way to do that would be to just connect to these two jumpers here, I think, at the rail. But there you can see it's slightly less than 4 volts coming out. So that's at 13 volts, and I will show the thermal image I took earlier of that. And right now I will turn the power supply up to 16 volts. And again, the changes aren't as rapid. That's because I think it takes a while for that's the fan of the power supply. I think it takes a while for the heatsink to heat up. So it's helping keep the component cool for longer. So the changes are going to take longer. And actually, yeah, it looks like it already dropped down. I can see the current is now at about 250 milliamps of current. So whatever current goes into the component from the power supply is the same amount of current that goes through the load. All it does is change the voltage, and the voltage that it drops just turns into heat. That's why we have so much heat. So let's first look at the voltage coming in now. Should be about 16 volts, as you can see there. And now let's look at the voltage making the rail, which is the voltage out. And there you can see it's about 2.6 volts. So it should hold about steady there. And I'll show the image there. So right now with the heatsink, not so good at 16 volts, but up to 12 volts it holds 5 volts at the output. And so we got a difference of 9 volts with no heatsink to 12 volts with the heatsink. So it helps a bit, and a larger heatsink would probably help a lot more, but this one isn't too big and it helps a bit, and it doesn't use any more energy like the fan does. And so now I have the fan in position, and we're going to turn the fan on. It's not on now, but we should see that we go from we have 16 volts coming in now, but we should see that we will rise from 2.7 to 5 volts. So let's show that again, that the output here, first the input is 16 right there with a little bit of loss, and then the output is at 2.6. And I'll move the thermal camera here. You can see we have a voltage drop at the resistor, and so it's not getting as warm, whereas the 7805 is getting really warm. So let's turn the fan on right there, and I can see the current slowly going up on the power supply, but in any case, it's hard for me to find a perfect spot to get the temperature. Looks like it's about 382, and looks like it might have just dropped a little bit. But in any case, we should see pretty soon that the 7805, okay, we're getting close now to almost, it's 410 milliamps of current, so looks like it's making progress. We should have a little more than about 4 volts, it looks like, coming out. So it's helping, but there, I think I got the fan in a better position now. Yeah, I can see current rapidly rising now. So yeah, fan wasn't on it completely. It's kind of blowing past it. But yeah, there you can see now we're already at 5 volts with the fan more directly on there now. And let's take a look with the thermal. So again, the fan's also cooling the resistor. But in any case, now we have the full 5 volts coming out. Alright, so now that's the end of the video. There's no way I presented this as well as I could. I'm sure the more I made these videos, the better I could present it. I could also get a better camera that could show you live on screen what's going on. But this is the setup that I got. So there doesn't seem to be a whole lot of interest in my thermal picture videos, and they take a whole lot longer to make, probably 3 or 4 times longer to make, as just diagram and build circuit videos. So once I actually film, it's not too bad, but taking the images on the camera, and then the camera seems to have to be fully charged before it will transfer to my computer, and then you still gotta like unplug it and plug it back in after it charges to get the images. And then I named the images and stuff and wrote on them. So this takes a lot longer to make. So definitely, if you like these videos where I use this thermal camera, make sure you use my Amazon link before you buy stuff, because that's really the only way I'll make any money on this. Not really making any at all with just the video views. But in any case, I had a lot of fun still taking these images, and I learned a lot. The fan did a lot better than I thought, and the heatsink didn't do as good as I thought it would do, because look how much more metal we have here to dissipate heat than just the tab and the backing, because it's almost all metal on the back of the component. But still, we have all this extra metal, and we saw how hot the metal was getting, you know, so we know heat was being transferred to it. But ultimately, we went from 9 volts, where the component by itself can still output 5 volts, to 12 volts, where the component can still output 5 volts. So even though we have this big chunk of metal, it didn't help all that much. But the fan, when I finally got it blowing directly on it, made a huge difference. So I'm sure a heatsink and a fan are just great, but this was as high a voltage as I could go, and the biggest heat sinks that I got. I don't plan to order anymore. But in any case, I look at purchases people make on Amazon after they click my link. I think it only shows me the US though, and only pays me for people that buy stuff from the US. It costs you nothing extra, but I can see what people bought, and that gives me an idea what they're interested in. So for one thing, it helps me make these videos, because I know there's interest and money's coming in from Amazon from people buying after clicking my link. You don't have to buy the camera, you can buy anything. And but otherwise, I just got to make what videos are popular. These are not that popular, so it's up to you. But in any case, thanks for watching, and I'll see you in the next video.